Now, for those of you who had me last year, this should look a little bit familiar. This is what I like to refer to as absolutely everything that you ever learned about stoichiometry on one page or less. This is kind of choose your own adventure style stoichiometry, if you will. So when you read your problem, you want to make sure that you can figure out what state of matter your first material is in and what state is what state do you want to convert into. So let's just pretend that my reactant is given to me as a solid. So what I'm going to do is go up to the top of the screen here and find where it says solid, and I would be taking my grams and put that over 1. And then I would use the molar mass to convert between moles and grams, and then continue. Now remember that the goal of all stoichiometry is to simply get us into moles so that we can apply a mole-to-mole ratio. Once you're in that mole-to-mole ratio, you don't have to go back to the same units that you did before. You can go to any new units that you need. So, for example, maybe I'm given a solid, and this is my pathway for having converted it into moles. But once I'm in that mole-to-mole ratio, maybe my product is a gas at STP. So I would actually want to flow down here and apply the conversion factor 22.4 liters to 1 mole for that gas at STP. Then if I pop an equal sign down, the unit that's left is going to be liters at the top, which is exactly what I would want, and that's how I'm going to be able to measure that gas at STP. So you can hook on any beginning to any ending before and after the mole-to-mole ratio that you need to accomplish your problem. So a problem may give you, I don't know, how about liters of a liquid, and then ask you about joules of heat that come out of it. So right here is how you would do your problem. You would have liters over 1, apply the molarity, moles over 1 liter, your mole-to-mole ratio, and then pop down to where it says joules. So you would apply your delta H over 1 mole reaction. This takes a little getting used to try and make this be extremely beneficial to you, but I think that this is probably the easiest and most concise way of presenting all of the individual concepts that can be boiled down into one quick and easy stoichiometry review. Outside of what you see on the screen, I haven't seen too many examples of any specialty or strange case stoichiometry. The AP board is actually pretty good about trying to keep their questions focused on large, overarching concepts. And I have seen more frequently on the free response section a question that is simply about stoichiometry and converting amongst all of these different kinds of measurements. So this is definitely something that's important to make sure that you conquer. If any of this looks a little bit confusing, or if you feel like you just need a little bit more, let me know. Let me know where your confusion lies, and I will see what I can do about clearing it up for you. I hope you found this helpful. I would definitely want to make sure that I practice with this chart and that I have this in my own personal notes. So good luck and have fun.